be extra good today since the camera's on. Oh, yeah. I'm pretty observant. Yeah, because he's trying to. You're a teacher, right? What does that mean? You're a teacher in training?
Yeah, I know.
You have to be classified as
Means I paid.
deemed good enough. You have to be deemed good enough. You're good.
Means I pay. I pay when
Wow.
Isn't that wrong?
Yeah, that
It's
is
so wrong. So. Alright, 13.3. Trigonometry. Or trig. Trig functions of general angles. Okay. So, have you guys gone over this yet? Sine, cosine, tangent, SOHCAHTOA, all that stuff. You know, adjacent over opposite, opposite over adjacent. How about cosecant, secant, cotangent? Do you have those as well? Okay. Just the reciprocal, right? I think opposite of sine would be, would that just be negative sign? Opposite.
Yeah, sine.
Would you consider that opposite?
I would.
Okay. So opposite over hypotenuse. Cosine is?
So,
Over hypotenuse. Tangent.
Opposite over adjacent.
Okay. Cosecant. What trig function does that relate to? Sine. Right? Sine. Sometimes you guys see the C, and you want to relate that with cosine. The cosecant is related to the sine. Cosecant of theta is the same thing as hypotenuse over opposite. Right? Because the reciprocal of sine is 1 over sine, right? And if we said that 1 over sine is 1 over opposite over hypotenuse, what do we do with this? Or whole number over a fraction. How can we simplify that? Multiply by the
reciprocal.
Reciprocal equals 1 times hypotenuse over opposite. Is that what we have right here?
Yeah.
This is how you can figure this out if you get stuck or can't remember. But it's pretty easy just to remember this. They're opposite. Okay? Secant is related to cosine. So if it's the reciprocal, hypotenuse over adjacent. And finally, cotangent is related to adjacent over opposite. It's related to tangent. So if it's 1 over tangent, this is the same thing as 1 over, how can we write tangent in the form of sine and cosine?
1 over opposite.
You guys know that?
No.
What tangent equals? Tangent theta equals sine theta over cosine theta. This is a good one to remember. Okay? Long? Remember this. Sine over cosine. Tangent. Okay?
Theta.
So that means that 1 over tangent is equal to 1 over sine over cosine.
Yeah.
Okay.
Bet. Sine over cosine. Theta. Theta. We have something similar here, right? So then we can simplify that by multiplying by that reciprocal, which equals 1 times cosine theta over sine theta, which is just cosine theta over sine theta. It's 1 times anything is anything. 1 times something is that same something, right? But cosine over sine is what's known as 1 over tangent, which is also known as the cotangent. Okay? Cotangent right here. just the reciprocal. Opposite over adjacent, adjacent over opposite.
So right now you're just proving to us like how.
Just proving to you how it works. Exactly. Okay, if you ever get stuck, and these are different ways that you guys can use to figure out, oh yeah, that's another way to write cosecant or secant or cotangent, okay? Really quickly, this is going back to last time. How do I convert radians to degrees? Remember that?
Pi over 180.
If I have negative 3 pi over 4, is this a degree measurement or a radian measurement? It's a radian, right? It's a radian. So I want to change this to a degree measurement. So don't I have to have radians in the denominator so my radians can cancel out? Right? And how do I measure radians? In pi. So what do I need up here? The 180, right? Because then my pi cancels out, my radian cancels out. And I'm left with just degrees.
Hey, good. Go fast.
Please. But yeah, no, I heard somebody say pi over 180. This is a way to remember this. All right? You need your radians to cancel out. So if your radians need to cancel out, you have to have radians in the denominator. Got that? Does that make sense?
Yeah.
Okay, similarly, if you started with 180 degrees and you wanted to change this to the radian measure, don't you have to have degrees down here to cancel? So what goes with my degrees? 180 all the time, right? And pi over 1. That's not a very interesting one, but your 180 does cancel out and the degrees cancel out. What are you left with? Just pi. It isn't 180 degrees, just pi.
Yeah.
Okay. That's just a little like time warp. Go back in time a little bit. Flashback. Okay. But I think there was some mistakes made on the quiz, on some quizzes about that. So that's just another way to think about it for you guys. Straighten things out.
We never had a quiz on this section yet. I don't know which one.
Just kind of like a review thing.
Yeah, that was just a little bit for review. Does that make sense?
It's been a while.
Okay now?
Yeah,
We're going to talk a little bit about some identities, guys. So these are known as what's called quotient identities. This is the tangent where you have sine over cosine. The cotangent where you have cosine over sine. Okay? Which we already pretty much talked about. All of those others are called reciprocal. Identities where we have cosecant, let's see, theta equals 1 over sine. You have the secant theta, which is 1 over cosine. And then, of course, we have the tangent, so the cotangent function, which is 1 over the tangent. So now you should have this in your notes twice, this stuff, which is 1 over sine over cosine, which equals cosine over sine. So cosine over sine is tangent, okay? This comes into much bigger play when we get to chapter 14, and you guys have to start simplifying trig functions.
do that this year?
Oh boy, I think so. The honors classes are doing it right now, so you guys will be doing it. And honestly, it's easier than the simplification you guys have been doing with cubes, you know, factoring cubes and factoring square terms, or, you know, so don't get scared about it. It's actually pretty straightforward stuff. It's just more work. No, it's fun though. This is like,
Oh, yeah.
once you guys,
This is so much fun. I'm having
I mean, you
blast.
Peters, when you guys graduate, you go, how many of you guys going to college? Everybody in here, maybe? I mean, hopefully.
Oh, come on.
You're going to Post
Don't
Academy,
fail out of it.
which is that's a secondary
Right on.
A lot of
education, right?
seniors are gone.
The more math you guys take for your degree, or whatever degree you guys choose, the more math you take, the more you guys will end up getting paid. I swear, that's how it works.
What did you say?
The more math you take in college, for your degree, if you take a degree that makes you take Calculus 1 and Calculus 2 and statistics, trig, calculus, you'll make more money when you get that degree.
You'll also be a genius.
What about like an art?
I'm not.
I'm gonna
So,
So.
you might not.
Trig, freestyle.
But that's not
Algebra
because
too.
you're gonna be.
Stop
isn't
me
your-
here.
Okay, I'm an exception. I'm an exception.
Yeah.
Yeah, I have to take Calculus 1, Calculus 2, Calculus 3, a bunch of these math classes. I've taken 13 upper division math classes.
So she's not
This is the lowest paying job possible I could find with all of that education. So I'm an exception. I could actually switch over to engineering quite easily and make $80,000 a year.
You should.
You guys. It's a good contribution to society, right?
Yeah.
Pays off.
And then
and I'm a pretty simple guy too. I have a little 95 Tacoma truck. Just this weekend I replaced the water pump and the timing belt myself. That saved me like $700. So if I was an engineer, I'd probably take it down, right, to the
Yeah,
dealership.
and just let them do it.
But I like doing that. I like doing that kind of stuff. Hands-on type of guy. No, I also have my real estate license too, so that helps.
Oh, that is nice.
So if I sell like, 3 or 4 houses a year,
So if you're selling houses, do you just throw a bunch of numbers at them when you're selling them?
just like confuse them to death.
This is super cheap, just trust me.
No, no, I'm not that guy. I've also worked in construction though, so I'm a buyer specialist, and I like working with buyers so I can take them into homes and show them what's going on with the house, what I notice as a builder's son-in-law about a house.
What made you decide to go back to school and become a teacher?
Oh, this is turning into Joel's life story.
Yeah. Tell us.
When I got laid off from being a wedding planner,
Oh, you're a wedding planner?
Yeah, that's a good thing. That's a good thing. You don't want to be a wedding planner.
yeah,
They're lost.
the Renaissance man. No, I was a wedding planner for 5 years.
Is that fun?
It is. It is fun.
I feel like you just ask people also.
Oh, Bredzilla's? Yeah.
Did you plan your wedding?
Yeah, I did.
That's probably
We
helpful.
got married at the courthouse, $300. My wife's
Super
wedding
loud.
dress. My wife's wedding
Just to get,
dress
like, more
cost her $100. Right? I rented a tuxedo for $110. She owns her dress.
You're doing all the
This is
cheap.
really, yeah.
Were you guys like young when you got married? Is that why?
No.
Or just?
I was 25 and she was 21. 6 months pregnant. It's one of those shotgun type weddings.
It's like that's very
Her dad had the shotgun. No, it worked out. It worked out. I got extremely lucky. But yeah, no, I guess at one point I just decided that, well, after I got laid off, it made it a lot easier to decide to go back to school. Because Obama made that thing where, hey, you can go back to school and get unemployment for going back to school. I was like, what a great deal. Go back to school, right? So, because normally you get laid off and then you'd have to go do a job search or 2 job searches every week in order to call in and collect your unemployment check, which mine was like $400 a week or something because I worked for so long. Made a decent amount of money. I think I was making $16 an hour as a wedding planner. A few years ago, that was all right money. And but I sat back and thought to myself, am I really making a difference, like in society, for society? Am I making a difference? Because someday when I die, I want to be able to say that I made a difference, right? Isn't that kind of what we all want to do in our life, is make a difference? It took me a long time to realize that. But yeah, so I decided to go into teaching. I was never really good at mathematics in high school. Like out of high school, if you would have asked me to become a teacher, I would have, no way. But went into math because I figured that was the best chance for me finding a job locally. Because we're established in Idaho, my family. My family, her family, we have a house. We have a rental house here, so I wanted to stay here. So math was
That's cool.
that was the way. Are there any other questions? You guys gonna applaud me? Applaud me? All right, let's get back into math here. Holy moly, that's like 15 minutes of boringness. Followed by some more boringness. Okay, so there's some vocabulary here. Standard position. Standard position of a triangle. If I'm in quadrant 1, if I say my triangle has point 3, 4, somewhere right there, right? The standard position means that my hypotenuse runs to my origin, and the other length of my triangle runs to the x-axis perpendicularly, so I have a 90-degree angle. Okay?
That's standard.
That's standard. And my angle of interest is always going to be the angle that's connected to the x-axis. I'm never going to be concerned about this angle up here, and I would never draw my triangle over to the y-axis. It's always down. So if I'm negative 3, 4, I'm up here. Angle of interest. Where did I draw my line to? The x-axis. Okay? This goes for every quadrant. Angle of interest. Okay? So standard position, all those triangles are in standard position. And the terminal side of my triangle is wherever my hypotenuse ends. So the terminal side is the hypotenuse side of the triangle. Okay? So for a few of the questions it says, it talks about the terminal side. And from that hint, you know which quadrant you're in. So, what's this quadrant?
1, 2, 3, 4.
Okay. Oh. So you guys are on it. I think the best thing to do is to actually go through some of these problems.
Yeah. Yeah.
So you guys have your books?
Yeah.
Okay, turn to page 788. 788 plus. And it is. I have a book over on the desk too, on my desk.
Is it still part of the
Mark's desk, yeah. Yeah, might as well.
Oh, dude. Oh, that's taken care of. Like, for someone.
Okay, so example 4 says if sine of theta is 3/5 and cosine of theta is -4/5, the terminal side of theta must lie in quadrant 2. The terminal side of theta must lie in quadrant 2. Quadrant 2, right? Let's draw the terminal side of an angle, of our triangle. Where do I draw the third side of my triangle to? To my x-axis, right? And here it gives us a lot of information. It says sine is 3/5. Well, sine is what on SOHCAHTOA?
Opposite over hypotenuse.
Opposite over hypotenuse. So we know that our opposite length is positive 3. We know our hypotenuse is 5. Exactly. They also say that cosine of theta is -4/5. And what's cosine? Adjacent over hypotenuse. Well, it's good. It's matching up, right? Our hypotenuse is 5. This is 5. So what's this? -4. And for these problems, it's important to keep this sign negative, right? It doesn't really make sense to have a negative distance or a negative length. But when we're working on these problems, don't drop that negative sign, okay? So it wants us now to figure out, I think it wants us to figure out the other, the exact values. Tangent, cosine, yeah, all these other guys.
So isn't that super easy?
And it's super easy, right?
Plug them in, right?
Just plug them in. So tangent, opposite over adjacent. Well, here's our angle. Opposite is,
3.
adjacent is, so it's -3/4. Cosecant is hypotenuse, which is 5, over opposite is 3. Secant, 5 over -4. Cotangent is -4 over 3. Okay? That's really easy. I can't imagine homework is.
I hope the one is that
I
easy.
can do that.
Okay. When we're thinking about x, y as an ordered pair of points, correct? Correct. What goes along with our x value as far as cosine and sine goes? I don't know if you guys have been shown this yet. Cosine is related to x, our x value. Sine is related to our y. Okay? This is also really important. Sloan, what goes with my x value? Cosine or sine?
Cosine with x and then sin with y.
Good thing I had it written up on the board, huh? You're looking at like ducks flying out there or something, huh? I saw you. Sine and cosine. How could you possibly memorize that in less than 5 seconds?
C always goes before S.
C goes before S. That's awesome. That's how I would do it. And X comes before
Y.
C comes before Y.
Bada bing, bada boom.
Bada bing, bada boom. Alright, so let's do one of these problems from the first section. It says, state whether the value of each function is positive, negative, 0, or undefined. So 17 is the sine of -135. -135 degrees. So if I'm traveling -135 degrees, guys, which way am I rotating on my unit circle?
To the clockwise.
Clockwise. Okay, I'm looking for clockwise or counterclockwise. We're going going this way, right? Positive is actually going around. So if we are going -135 degrees, have we passed pi, negative pi? No. What happens when I get to this point? Have I gone too far?
No.
No, just kidding, sorry.
Wait, yeah, you have.
Wait, yes, you have.
I think you have.
I'm at negative 90 right now. Negative 45, negative 90. How much more do I have to travel to get to 135? 45 more degrees, right?
Yep.
So I'm right here. This is my line that I'm interested in, correct?
Where you at, like?
So-
7
Is the sine of that angle positive or negative?
Negative.
Why is it negative?
There's a negative.
It implies negative.
Is that because how do you know that?
We went,
How do you know that? That's what I want you guys to be able to
because
tell.
we went clockwise around the
I don't know.
circle, right? We went,
It doesn't matter which way we go. We could have gone clockwise far enough to make this thing positive.
true, but it was a
The reason why it's negative, sine is related to what? X or Y?
X. Oh, why?
Sine is related to Y. As far as Y goes, am I negative or am I positive?
Negative. You're double.
I'm at this point.
Oh, so it's all relating back to quadrants.
So if I draw a perpendicular line over to my Y-axis, is that Y negative or positive?
Negative.
Negative.
It's negative. That's why sine of negative 135 is negative.
so
If I would have gone sine of negative 270?
how do we know that sign is negative? Just because there's a negative sign?
No. You know that it's negative. Negative 135. We're at this point right here, right?
Yes.
Sine is related to what? X or Y?
Why?
Is my Y negative or positive? If you drew this point as an ordered pair point, would you make it negative or positive?
Negative.
It'd be negative, right? It'd be a negative X
Because we're.
and it'd be a negative Y, right?
Yep.
So how do you know if you're
So
doing
like,
like
it's all related to quadrants.
It's all related to quadrants.
going to negative 135?
This sign will tell you if you're going
No,
clockwise.
I
or
know, but
counterclockwise.
like, how did you move? Like, do you always start at the same place?
You always start at 0.
Okay.
This is our 0
So
angle.
then if it was like 60, what would you do?
Go positive 60?
Yeah.
And go positive, let's start positively,
Okay.
and go 60 degrees. These red sections are in 30-degree sections, right? 30, 60, 90, 120, 150, 180.
So sometimes it'll just be like 60 and you just go to 60.
Yeah, if it was sine of 60, I would go 30, 60, it'd be at this point.
But it would be positive.
Well, is that Y value positive or negative?
Positive.
Positive, right? Because if I draw a line over to my
And the
X,
X would be positive.
the X would be positive too. Miller.
I think it'll like be asking questions like what sine 5 pi over 4, and you have to see if it's negative or positive.
Yeah. So, you guys have this in your notes yet? The unit circle?
Yeah.
Yeah, this would be a good thing to have in your notes. And to have on your note card, for taking the test.
When's the test?
I don't know.
Oh, not for a while.
I don't know when the quiz is.
For a while. So what if the X was negative and the Y was positive?
If the X was negative and the Y is positive, what quadrant am I in?
2.
2.
Right?
X is negative, Y is positive. I'm up here somewhere, right?
Yes.
Well, this is kind of a special case of that. So sine of negative 270, which way am I rotating? Counterclockwise or clockwise?
Clockwise.
Clockwise. Where do I end up?
Keep going.
Where's negative
It's
180?
positive
That's for
270.
dollar.
Right there.
I got it for a dollar at Walmart.
You guys see that? I end up at negative 270.
Stop.
Is my Y value positive or negative?
It's positive.
So here's
You have a
positive.
visitor.
Alright. You guys bring me coffee?
Oh,
Oh, okay. What's up?
Sorry, I was just wondering, if I could get a quote for
Oh, yeah, he's not here. He'll be back Wednesday.
okay, thank you.
Yep.
Is somebody supposed to be bringing this?
So here we see 2 different examples. Sine of a negative value that was negative because we didn't rotate far enough. Sine of this negative value actually got us to a positive situation, okay? And they can throw stuff at you like cosine of pi over 4. Well, if we had cosine of pi over 4, Ripson, what's so funny? Tell me, you want to know?
There's no.
I like to laugh.
You weren't laughing.
You're making him laugh?
I swear there's no funny joke. If I could make one up off the top of my head, I would, but.
Alright.
Come on,
So
man.
something that's positive.
Sean, pi over 4, am I in degrees or radians?
You're in radians.
I'm in radians. Am I traveling counterclockwise or clockwise?
Counter.
Counter?
Counterclockwise.
Final answer?
Yeah.
$1 million on the line.
Alright, I'm gonna say, counterclockwise, yeah.
Okay.
Use the light on it.
Good, buddy. Here it is right here, pi over 4. Pi divided by 4. 180 degrees divided into 4 sections, right?
Yeah.
1, 2, 3, 4. So pi over 4. Is my cosine related to x or y?
X.
X. Is my x positive or negative at this point? So this is positive.
How would you know if it was like 0 or undefined?
If it says cosine of 0 degrees or cosine of, sorry, not cosine of 0 degrees. Sine of 0 degrees is 0. So if you guys were to graph on your graphing calculators the sine function, it looks like this, where we start at 0, we end at 2 pi. We start at 0, 1 full rotation, we end at 2 pi. 1 full rotation, we're ending at 2 pi. And we're traveling up, just like this point, we're traveling up. And that's what's called, well, I guess you might as well put this in your notes too. That's called a period of rotation. It's 1 rotation.
Makes sense.
That answer,
Yeah, I
I
got.
just totally,
No, well, I was just trying to like, because in the book it says, say if it's positive, negative, 0, or undefined. So I guess you just answer to 0. But how do you know if it'll be undefined?
that'll be 0. Sine is 0 here. It's 0 here. What would this value be?
1.
Sine is related
Y.
to
It's
y. Where is y 0?
It'd be undefined because it's not
No.
positive or negative.
It was 0 here. It was 0 at 0. It was 0 again at 2 pi, but somewhere in here, my y value is 0 again. Isn't it 0 right here when I pass through this point?
Yeah.
Isn't it 0 at pi? So that's pi.
Okay.
Okay, and these functions travel between 1 and -1.
So on every graph, it's going to be a pi.
So at this point, pi over 2, my y has traveled the furthest height it's going to travel. Right? I can't get any higher on the unit circle than at this point. I can't get any higher on my graph than at this point. So that corresponds to pi over 2. So when you plug in your calculators, sine of pi over 2, it'll give you 1.
Okay.
I get it now. Not really. I thought I got it, then I lost it.
It's a little bit circular.
But you guys don't really need to worry. Don't stress yourself out about this. Your homework's not really on this one.
We should do an example problem.
Yeah, we should do like some of the homework
That's what I'm
together.
thinking.
Hey, let's just do the homework.
Let's do.
That's not how homo.
All right, find the exact values of sine, cosine, tangent.
Alex,
With the terminal side. Guys. So what?
If cosine is 0, then does that make it undefined?
If cosine is 0,
You stumped me.
Good job.
You broke it.
cosine of 0 equals 1. If you look at the cosine graph, remember how sine started from 0 and went? Cosine starts at 1. and dips down, and it comes back up.
So is this graph thing, is that supposed to be like relatable to its circles?
Yeah, it's totally relatable.
I don't see a relation. I see
Okay,
a circle and I see lines.
So it's just supposed
As
to be
it
a
goes
circle like
up,
on a graph?
when it gets to its top, like its highest point,
That's,
it's 90. And then if you go down
The lowest,
again,
it's 270.
yeah, it's 270.
Oh, okay.
Yeah.
I guess I'm.
And
Yeah.
then if you go to the
And then
side,
when you
it's
meet
Sorry.
it, when you meet it, and then when it gets right on the zero
So this is
axis.
3
I
pi over
I see
2.
what you mean now. All
the way I
right.
see it is you could take that line
But at 3 pi over 2,
and flip it back over to.
where's my cosine?
But it's just like the circle's
This is
like.
all I
You don't
got.
have to.
At 3 pi over 2, where's my x? Is my
It
x?
basically
negative
is on the
value or is
outside
my
of
x
the
positive
circle.
value?
And unlike
Positive? Negative.
Guys, listen to me. We just said that sine is at its negative most point here, right? Which is 3 pi over 2. But at this point, my cosine is, what's my x value?
0.
0.
That's what I said.
That's what you said.
I swear it's 0.
So the lowest point you could possibly get to is
That's
270
zero.
or 3 pi over 2. That's the lowest point of like,
Right.
the graph. All right.
Yeah. And you can keep on going around in circles and circles and circles, and the sine wave just keeps on doing its thing, sining.
Signage.
So if I calculate a graph.
Okay? But let's do a problem. We're getting kind of distracted.
Definitely do it.
Okay, find the exact value of sine, cosine, and tangent if the terminal side in standard position contains the given point. Negative 15, comma 8. So we have an ordered pair of negative 15, 8. What quadrant am I in? Over 15 of 8, right?
Yeah.
So this is our triangle that this is describing. Our terminal side is running through the point, negative 15, 8. We've gone negative 15, so we know that this length is negative 15. What's this length? Positive 8. And it is, because we're going up, right? How do we figure out the hypotenuse length? Pythagorean theorem. Somebody help me.
A
X
squared plus
squared
B
plus
squared
negative
plus C
15
squared.
squared equals something squared.
So 15 squared plus 8 squared equals,
Wait, shouldn't it be
should
negative?
I don't think it matters.
It doesn't.
Oh, because the negative and, okay.
It doesn't matter.
So it's going to be between, well, I guess we don't know, it's going to be between, it's going to be bigger than 15, right? So that's how we found our third length, Pythagorean theorem. You guys know that? Piece of cake. Peters, why are you looking confused?
No, why you put 17, because negative 15 squared plus 8 squared is not 17.
Yeah, but you have
But
to
you have
then
to
square
square root
both
it out.
sides.
Oh,
That was
okay, okay.
Where's the question on in the book?
It's 26. So now, that's the hardest part. That's the hardest part. What's sine?
I see what you mean.
No. Opposite over.
So let's say 8 over negative, or 8 over 17.
Sine is
8
8 over 17. What's cosine?
Negative 15 over 17.
Yep.
Negative 15 over 17. Tangent?
8 over negative 15.
8 over negative 15.
All those
Well,
columns
Well,
right
we
there.
have to do all of them.
7 over 8.
But that's what this is asking for,
Yeah.
okay?
This is 13.3 here too.
17.
So if you had like square root of 2.
Let's go to 40. Let's go to 41. Cosine of theta equals,
That is all we have to do for a problem.
yeah,
Is fill in SOHCAHTOA what?
seriously, yeah,
Oh,
like that's what I said.
that's so easy.
Good. Good, I want it to be easy for you guys. All right, let's go to 41. We're in quadrant 2, lets us know that. it also lets us know that cosine of theta is -1/2. So I would write up here, I'd say, okay, cosine of theta equals -1/2. Well, what is cosine? Cosine is
Adjacent over.
adjacent over hypotenuse. I'm in the second quadrant, it tells me that. So I know that my triangle's gonna look something like that. I don't know if it's higher or smaller, but it's gonna be that triangle.
Does it really matter?
Doesn't matter, because that's the visual representation that you guys can use to help you solve, okay? It has to be a -1/2, but my hypotenuse is what? 2. And my hypotenuse is always positive. My hypotenuse is never negative. Write that down. Hypotenuse is always positive. So that forces my adjacent to be what?
Negative.
Forces it to be negative. Forces it to be a -1. And hey, look, I had to travel -1 this way to get to this point. Makes sense. +2. So what's this length right here?
So,
1 squared plus x squared equals
so what happens if that
equals
2?
4,
What happens if it wasn't negative in the hypotenuse?
right? Because I just squared the 2.
So can the hypotenuse not be the x squared? Like that 2 can't be 2 squared, or be the x squared? I thought it didn't matter what order you were
1 squared plus x squared equals 4, right? 1 squared is plus x squared equals 4. Subtract 1 equals 3.
Sweet.
Square root it.
Could we just leave it like that?
Root 3, just leave it there.
Let's keep it as root 3, more exact.
And you didn't do -1 because if you square rooted 1, it would be, or -1, it would cancel right there, right?
Well, -1 squared is -1 times
what I'm
-1.
saying. That's just one. I was just making sure.
Yes. So that's how I figure out this length. What does it want us to do now?
Find the rest of them.
Oh, it does want to do all of them. Okay.
Let's not do all.
Sine. Opposite over hypotenuse. No, this is a good one.
-3
Root 3 over 2. Cosine. -1 over 2. Tangent.
-3 over
Root 3 over
-1.
-1. Cosecant.
2 over. I'm getting mixed up because these things aren't here.
2 over root 3. When you guys have a radical in the denominator like this, you have to get rid of it.
Can you cancel it out?
Multiply by.
So 2 over the square root of 3. We have to get rid of this. We're going to do it by multiplying by 1. But we're going to multiply by 1 in the form of whatever that radical is over itself. Okay? Because when you do that, the bottom denominator just turns into 3. Square root of 3 times the square root of 3 is just 3. Okay? The top is 2 root 3. So that's your answer to that one. That was a good problem for us to go over because it exposed the problem that you guys were going to see.
How did you know that it was cosecant? Like, how do you know that's the one we were using for that?
I'm just running through these 5 functions.
And then and then that one we
Whatever.
just came across and it was just wrong, so we had to fix it just
Yep.
either way, regardless of whether we're using it or not.
Yep. Over opposite. Oh, yeah, okay. So let's go to cotangent. Cotangent is adjacent over opposite, right?
Yeah, -1.
Over the square root of 3. So here we have that same problem. So multiply by root 3 over root 3. So we have negative root 3 over 3. Okay? That's 41. That's all those. I'm going to let you guys kind of stumble through 32 through 40. I don't think you're really working on one of those. But I think you have enough in your arsenal to get through these problems. Okay? Pay attention to what quadrant you're in. These problems give you enough information, obviously. We're doing 18 through 24 even. You guys ready for this? 26, 27, 29, 30, 31, and 32 through 46. Even. Page 788 plus. So I'm gonna go to the bathroom.
I go to my local to get more people.
To get more people.
Oh.
Come on, man. There'll be a
Pulling little
halt.
people out of your
There'll be a
locker
heart.
still.